Hello everyone. Today we'll be looking into MicroProfile Rest Client. This is about consuming RESTful APIs. So if you have a microservice who wants to communicate with another microservices, then this is the right approach. Uh, Most of the developers generally use manual implementation approach, but REST client is specification simplifies creating RESTful clients. So this is what we will be covering. What is the easiest and simplest way if you have coded a microservice, which is a RESTful microservice, then exactly similar is the process to create a client service which will consume another microservice. So this is what is I'm describing in this session. So you don't have to manually write HTTP request or parse responses or manage errors. We'll be using an approach which will be doing all this through a framework, and with minimal coding we'll be able to achieve very production grade REST client. So we'll be leveraging RESTful Web Services or JAX-RS, and whoever is familiar, they will find this really easy. This approach they will find very easy to work with, and there is no HTTP logic, low level networking logic. Everything which we'll be doing is based on the target services endpoints. We will be generating interfaces, and we will be following an approach which is uh, mostly it will be dynamically generating the interfaces and also automating HTTP communication. And this will be done also with the compile time type safety. So all the clients which we will be generating, they will be type safe. That means you can detect any uh, parameter mismatch or response request data type mismatch at the compile time, and you don't have to deal with a lot of runtime errors. So let's begin. Let me start coding, and this will be live coding session. You can also code with me. And if you have any RESTful web service, then it's fine. Otherwise, you can do this using any existing REST service. So let me go to my GitHub repository, and then I will start as always a code space. So I use GitHub code space. I have shared details about code space in our previous videos. I have also shared about uh, so to start code space, you have to go to your repository, and then within the code there is an option code space. You can either clone the code locally, or you can run a virtual machine which will have a Visual Studio Code IDE, and this is more handy and easy. So that's why I use this. So let's further start implementing this. So here is my code which is getting loaded. In my previous session, which was earlier this week, I have shared about what all plugins I'm using for building the code. I have also shared how to build a microservice, which was a catalog or product microservice, and we will be now consuming that microservice. So we were anyway uh, talking about that what is a RESTful client. So RESTful client, there is a specification, and many frameworks they implement this specification, and this specification defines various annotations. Annotations are like get, and they have a declarative approach. So here you don't have to deal with logic, low level logic, HTTP details you don't have to code, but you have to be aware of your interface, of your signature of methods, parameters. So there are various defined method signature, and then you have also defined annotation which you can apply. And then based on the qualifiers, it will ensure that this classes of the client is generated, and with compile times type safety. So you don't have to take care of lifecycle management. So we will be using CDI. CDI is context and dependency injection, and we can do externalized configuration. So I will cover all this, that your web service endpoint would be changing, and you can, better approach is always to have a configuration where you will define the URL, and then your code will take care of automatic dependency injection, lifecycle management. So you don't have to take care of cleaning up your client, and you will be able to build a client which is stable and can work very effectively in the production environment. We'll be achieving full alignment with the standards, which is JAX-RS, or now this is called Jakarta EE10, and RESTful Web Services. And this, when we will make our code which is complying to these standards, this means that you can run in various runtimes which are complying to Jakarta EE standard. So you get the complete ecosystem of runtime environments, whether it could be Open Liberty from IBM, WebSphere, or it could be any Java runtime from Tommy, Apache, or Payara, or there are many from JBoss, Wildfly. So the code which we will be doing will be running in many runtimes, which includes even Quarkus and many such runtimes. So here we will start. We are into IDE, so we will start coding also. So some of the important annotations which we should understand is about get, post, put, delete, patch, add, and options. So this, you know, are the HTTP methods. They are also supported in JAX-RS, and they will also be used in REST client. Only the package is different, but the annotation is same for REST client and for RESTful Web Services or JAX-RX. So these are different kinds of parameters, which could be path parameters, query parameters, header parameters, cookie parameters, form parameters, bean parameters, and matrix parameters. So you can watch my previous video on RESTful Web Services. There I have described in detail. So I have in this channel videos about basics of REST, what is REST protocol, what are their advantages, and what are the best practices for building REST web services. Then we have built REST for web services on Java. So we have a detail about JAX-RS, and then now we are covering in detail REST client. Earlier I have also covered REST client, but not in that much detail. This is a very thorough session, and here we will be using some of the most modern approaches for building REST clients. So some code, yeah, this is the code which is very important part. Like, you have to inject a REST client, and you have to create a client interface, and then you have to inject an instance of the REST client interface. So it's very straightforward. So there are two approaches. One approach is we can use the CDI injection, context and dependency injection, and with the help of qualifier REST client, you can build. But also there is a possibility of creating a REST client builder, which is about builder pattern. And builder pattern is a very interesting pattern. It simplifies creation of objects. In this case, it will simplify creation of a REST client, and we can provide base URI and various other attributes to the client. So what are the benefits of these approaches? We already discussed that this compliance, you will have support, you have flexibility, you have optimization for deployment to the cloud, less memory footprint, faster startup. Then you have other tools and frameworks and libraries will also be compatible. So we will be using here context and dependency injection. We will be using JSON binding and JSON processing for parsing, and for serialization and deserialization of JSON objects. We'll be using bean validation for implementing validations, and we will be using Java 21 LTS release, which is the latest LTS release prior to Java 25. And we will have very less learning curve. So this you will understand when I will code. So here, let's look into what is our service, and let's run the service. So I have a code folder. I have here the chapter folder. Then we have here various services. So I have implemented microservices for entire e-commerce application. So I started with a catalog service which has list of products, and then we have an inventory service which has stock details of each of the product items. Then we have order service. So someone who wants to buy will first add the item in the shopping cart. So we have a shopping cart microservice as well. And with this shopping cart microservice, you can add the items which are having stocks available into shopping cart, and then place an order. And when an order is placed, it will also call the payment service. Payment service will implement the payment, and then once the order is confirmed, shipment service will start initiate the shipment of the item. So this is all about the life cycle of or all the microservices, how they interact with each other. We also have a user service which is for authentication of users, because for some of your services, like for example accessing your shopping cart, you need authentication. So this e-commerce scenario is the best scenario for understanding microservices and its benefits. So let me also sign in the chat so that I can also take care of any queries which are coming, and I can answer them in the live chat. So let's come to our catalog service. So here, first thing is I will go to the directory where I have the code. I am inside the directory. I'm just making my screen a little bit bigger so that it is easy for everyone to look into the code and understand. So I'm right now in the terminal, and I am in the code directory, and there we have code for all the microservices divided into various chapters. So I'm going into my project, and my project is catalog. So I'm inside the catalog project, and here I have pom.xml file, which is the dependency and build management file. So if I have to run my product service, I have to first compile and package it. So I will run mvn compile and package command. This will compile and package, and definitely it will run the test cases, and it will take care of running it, making package deployable so that it could be run. So here you see that it looked into the package, it has compiled. So first it ensured that every classes and packages are downloaded, dependencies are downloaded. Since this is a build which I'm doing, no, not the first time, it's like I have done it before. So It has done very fast, and it has compiled all the classes successfully. No compiler errors were reported, and then it has run the test cases also. So if there are test cases, it will run. So in this case, I didn't had any tests to run, but if you have unit tests, that could be run, and then build is successful. So it will create a var web archive, which is ready for deployment. So now we have Open Liberty as a runtime environment, and I will run this application or microservice. Now I'm giving the command mvn liberty dev. This will start the microservice in dev mode. So there are two commands. One is mvn liberty run, which will run it as a production, and dev mode will run it in debug mode. And another advantage of this is hot code deployment. That means if I am making any changes in the source code or making any changes to the configuration of my runtime, then automatically these changes are picked up, and I did not have to stop the server, restart it, and redeploy my updated code. So it saves a lot of time. So now our application is running, and it's running in port 5050, as we can see. So let me access this service so that you get to know about what this service is all about. This service has a context route, which is catalog. Then I have API and products. This service will return list of products. So this is our service, and now we will be building a client for this product service. So now you see here, this is the JSON response. This is the response which we will be trying to consume in our other microservice. So now coming back to the other microservice, the other microservice will be called, this is payment service. So in payment service, you have to verify that all the products are valid and they are available, and you have to get the details of the price, product, for processing the payment. So this is what we are planning to do now. So let's build the REST client. As I shared, there are multiple approaches. So one was the approach using CDI. Other is the approach using REST client builder. Earlier, we have to build the REST client builder, you have to pass on the URI. So you have to create a URI object and assign it to your REST client builder. So this is slightly simplified in the latest version. So let's look into a code which is within payment service. So I'm just going inside the payment service, and in the payment service, I've already implemented the REST client. So you see here, there is a client package, and within the client package, I have product client. This is a simple product client. How it's implemented, you can understand from here. So here is for the catalog service, or it's called product service. So here we have one interface which is registered using annotation register REST client. And there is a register provider to register custom exception mapper. There's config key for external configuration, type safe methods. So a lot of things are there here. So first thing is I will register REST client, and config key is catalog service. So this is what does this mean? This means I can configure this with microprofile microprofile configurations, or what it means is I can put the properties in resources meta-inf, and there is microprofile config file here, and this will contain my configuration. So catalog.service.url, this is the URL for the product, and this is the fallback URL in case the above URL is not available. Then this is the fallback URL. This is the timeout URL. So it's all best practices to define how will you fall back, how will you time out. You may also define retries. So this is the base URL. So I don't have to put all these in the code. I can change this, and this will be picked up by the runtime, and you again don't need to patch or update your microservices. So you have connection timeout, you have read timeout, and you have defined also the scope of the bean, which is application scope. So the scope the bean will be running uh, until the application is running. So this is all about our client configuration. So this is what we need to understand right now. So next, let's go to so yeah, we were in a code folder. We already started the microservice, and there is one way we have implemented the client is using Swagger. I have a previous video where we discussed about Swagger in detail. Now I will again show you how the Swagger was, so that you can understand. Swagger also generates a REST client which is on the web. So you see here, this is my product service, and here we have various methods. Get products, I can call this using this interactive documentation. It retrieves a list of all products, and when I click on execute, this makes a real call to the microservice and will return the result. Since the microservice is running right now, so it's returning the response. So you have here a lot of features. For example, here is your REST execution uh, form where you can execute, and I have even here a form. So if there is a REST API where you have to provide multiple parameters, then you have parameters could be provided here. So you have here various options. So for example, I can search for some item, for example iPod in this case, and it will return search results which will match this query. So here nothing matched. I can say iPhone. Now iPod is not very common. iPhone has replaced iPod. So you see here the result has returned. So you get a form for building the parameters, and then you see the response again in a very well formatted, structured manner with response headers. So you even get the curl command, which you can copy paste in the terminal to call this service. Now, in case there is you have to pass on the body, request response body, then you have a request builder. So here I can say that, okay, I want this ID, I want to update one product, and I want to put the name change. So for example, here we have ID1, Apple iPhone 15. I want to update it to say Apple iPhone 15 Plus. And then there are other details as well, which we can modify. So for example, this is the description, name was this, so I can update that very easily here. So this is not the name, this is the description, and then we have here the name. We can just say iPhone and 15 plus, and then there could be a price here which we can define. We can say that this is $5.99, and then when I will execute this, this will update the product. So this call is going. Now this product is updated because we have received 200 response, which is okay. And then if I do the get request again, I will just give me a minute. So yeah, now when I will do a list, I should see that the products are updated because the price is changed to 599. So this is now updated. So this is about Swagger. This is the functionality of the REST API. Now I'm coming to REST client. I'll be implementing it programmatically and calling this service. So here again, I'll go to the client code, which I just showed. Here we have a payment service where we will like to retrieve the list of products. And in this, I have a package, which is, so I'm inside a payment service, and within payment service, I have the client package, and I have defined here a client. Product client is this is auto closable. So here I have interface here. Interface will have all the methods. So I would like to get all products. I will also want to get product by ID. So the payment service will only read the product details, and anyway do not create new products. So now let's look into earlier approaches, how we used to do before REST client. So you see here, you have to define a class, then you have to define a method, and then you have to do a client builder, create the URL client with the target URL, and then you have to mm, define an array of products and which you will get as a response. So you have to take care of a lot of JSON parsing code. So here, no, again, I have similar code. So you read entity method, and here read entity method will have all the logic to read the data, right? So you have these products, and then products you will kind of go through, you will read each of the objects in the JSON. So there's a lot of JSON parsing and request building, passing on header parameters. Say for example, here I'm building the request. So a lot of manual work required previously. And if you have so this was a simple example. And if you have little complex example, the code increases. So here you have here more complicated code. Now this is very much simplified. So we defined an interface, then we have configurations, everything defined in so here we have the payment config. This is not used right now here in this client. We have here a demo client runner. So this is one the previous example where you would like to run this in as a test. So here now let's run this payment service as well, covering later. But you should understand here we have a payment service. Let me describe about the payment service. Payment service has payment details, which is card number, holder name, expiry date, security, amount, etc. We are not interested in description because as a payment service, the item is already added to the catalog and we only need to process the item for getting it. So we have here the REST application, which is the payment REST application. So no configuration here. very simple. So here is our service. So you have a payment service, and in the payment service we have let me show you the code in detail. So we have an authorized payment endpoint. So here we can process payment. Process payment using payment gateway. So it will make a call to the payment gateway. It will return the result. This is the API, which is process payment. Now coming back to the REST client, we have defined a product catalog service, and this is application scoped, and this product catalog service will have injection of the REST client, which is product client, and we have a method get products. In this, we are calling product client dot product get product by ID. So this is one of the method. We will also have a method to get all the products. So this is all the products. We have a method to check whether the product is available. This will read the availability information. So basically it's checking whether the price is not null and product is not null. If the product exists, then it is available. So there is a Boolean flag also to describe that availability. So these are the methods. So now let me run the payment service. And we have used two approaches. One is the client, which was the earlier. It's so simple, no logic. It's just annotation. So this is another approach. Here you have a base URL, you have connection. So this is as per the builder pattern. I have also an article on builder pattern. You can, I will share the link in the description about the builder pattern. It's very useful, and here you can see that here timeout, read timeout, everything we are setting in the program itself. So if you have a logic where you have to, based on certain conditions, decide the parameters, then this REST client builder is useful because it will dynamically generate a client, and the other one is statically generating a client. So here there is dynamic configuration. So this is what the example shares about. And this could be interesting because if you have a service which has different endpoints in production, in testing, and in a staging environment and dev environment, you can use something approach which is similar to this particular code. But yes, let's look into our payment service. So we have just a post annotation, and we have, so this is the payment service, but product catalog service is very straightforward. So here you have get all products as method, and is product available, and then get product by ID. So these are the methods. We have already defined this interface, product client interface. So here very minimal annotations are needed. It's just calling the product client and then calling the appropriate method. Now to compile this, I will open another terminal. I will again go to the code folder. So now I am inside the folder where I have the payment microservice. I'll again compile this code, and I will also package this code because I need to then run it. All right, so the compilation has successfully happened. I have already catalog service running. I can stop it by pressing Q for quit. I can run this in the run mode because I don't want this to be running with debugger. I can put payment service on the debugger. So that's why I kind of switched off the debugging from here. And now I'm inside the payment service. Let me run this in dev mode because when I will be changing the code, automatically it will be doing hot deployment. Now ambient dev. So this again, the project is getting built. It is using MicroProfile Rest Client 4.0. It's also using the JSON binding, JSON processing, authentication, and is also there. So a lot of uh, specifications have been implemented here. So this is a code which is uh, runnable in multiple runtimes. Now we are opening this in the browser. Okay, so let me come back. I go here and I'm opening a new browser window because I want to run not the product catalog service. I want to run the other service, which is the payment service. So this is the URL because the port is different. It's here the port is 9050. In other service, the port was 5050. So what Eclipse, GitHub code spaces does is it creates another URL. It does a URL mapping. A port is mapped to another URL because I'm running it in a virtual environment. And in that environment, I can't go to 5050 port because that would be blocked by the firewall. So the port redirection has happened here and it's mapped to another URL, and this URL I can connect to. So this is my product service. This is my payment service. So let me go to the payment context root, and this is here the path for my payment service. Let me look into the endpoint using Swagger because yes, only the process authorized payment is there here. And then there are payment / product endpoints. So you see here I have various endpoints with the payment service authorized payment config. This is to read the configuration and this is to process the payment. Then you have get all products. This is what we'll be calling the endpoints. This is what we'll be calling the REST client. So let's try this. This will read the products. I have restarted my product web service, and this product web service was using in-memory cache. So that's why we have updated this iPhone product, but this update has been reset because we had the in-memory data storage, not the database storage. So that's why we are getting these values. So here you see that this REST client is calling and it is getting the details from the other service. So let me come back here and let's look into our more concepts which we will be covering here. So the concepts which we covered, yes, so these are the concepts which we have covered. We have seen how to create and inject a REST client. We have seen how to create a REST client using the builder pattern, programmatically creating. Now there is something which is called multi-form data. So we can do something like file upload also using REST client. So these are the benefit, which is portability and standard compliance. You can have long running process also supported here for batch kind of scenarios. We can have fault tolerance integration. We can have error handling custom providers. We can have propagation of headers and cookies. You can create HTTPS and security configuration, and then you can handle redirect response, and then you can have asynchronous execution as well. So there are so many features starting from type safety, declarative API, context and dependency injection for automatic lifecycle management, and the configurability. So these are various benefits which we have seen. Now dependency, this is how we define the dependency in the POM. So if I go to the pom.xml of the payment service where we have defined the dependencies. So you see here POM XML file has the Maven plugin for generating the var. Then we have a Maven plugin for Liberty, which is what we used, Liberty Run, Liberty Dev. We are using Java 21. We have a compiler plugin to compile our project. And then we have JUnit plugin for running JUnit test. We have MicroProfile 7.1 and Jakarta EE10. So we are using all the standards here. So I haven't specified client separately. I have specified overall container package which will include this. So if you are using Gradle, then this is what you have to define. Then we have this interface, product service interface. This is how we define a method, and this annotation specifies that this will get, this will make a get call. So we don't have to create low level HTTP calls. Then we have to inject this product client into the service from which we are calling. So here we have various methods. One is check product and is product available. So earlier we had this kind of declaration. Now this is REST client has been made mandatory because this was avoiding confusion, making the code readable, because you can have different kinds of beans. Now we can have multiple REST clients in any service, and we can manage the scope here. Scope could be request scoped, application scoped, session scoped, and dependent based on the scope of the injection point. But yes, the first three are the most commonly used one. This is generally used when you are building something like frameworks. So these are the advantage of dependency injection. So that means it makes the code easy for lifecycle management, automate the lifecycle management. You can have external configuration, you can have testability, scope aware, resource sharing. So there's a lot of advantages, and consistent dependency management. So these are the advantage of context and dependency injection in REST clients. And automatic resource cleanup. So you don't have to take care of cleanup. We saw that the interface which we defined was auto-closable interface. So then you don't have to take care of dependency management, cleaning up or deconstructing the object. So we defined registered REST client config key. So this is registering the config key. and then you can specify various fields. So this all we have seen. We can also configure the scope. We can configure the filters. So this is what we will learn next, how configuring the filters. So we can configure it to follow redirects. So configuration can be done in multiple ways. One is with application.properties. MicroProfile application.properties is the way where we put the configuration, which is as key value pairs in the property file. Other ways to do it is using parameters in the command line or using environment variables. So these are various ways of configuration, and the another way is programmatic configuration, where you can, based on some condition, determine the configuration and apply the configuration to a web service. So I have details of all the best practices. So this I'll share so that you can look into it later. Now using path parameters. So we have used the path parameters, get product by ID. So if you see in my code, so we have, this is the payment service, and some services are using the parameters, and parameters are path parameter. So for example, here from the catalog service, if we want to get a product, so for example, product with ID 1, when I execute, it should return me a product with ID 1, which was iPhone, and this is the response here. So same, no, I can do it in my browser as well, because here I have API, then I have catalog. So let me just double check. So here API, catalog, products, and ID. ID I can give 1 or 2, and this will return me the JSON response. So 9050. So okay, I'm trying it out in the wrong server. I should go to the another path, so which is let me update this. So here, instead of, now it should take me to the right service. So here we have the 9050 as the port, then API, then catalog, product. So this is ID, this is the get response. API, catalog, products, and ID. And the server is with 9050. This is the URL. And okay. So here we have the payment service. So the base path starts with payment. Now it will return me the JSON. So you see here, I have got the JSON of the response. If I put another ID, we'll get the another JSON as response. So this is getting a call to the client and then retrieving. So this is about path parameters. Next topic which we were looking into is query parameters. Query parameters are some product by category. Say for example, electronics. So here where we have the query parameters, but yes, I can share you where we have something like search. So let's look into that kind of service. So another service here, price range. So if I try it out, if I say maximum price is 1000 and this is 0, these will be query parameters because they are not in the path parameter, these are in the query. So when I execute this, it will return me all the products. I think all the products are within this range, or two products are within this range. Third one was 12.99. So you see here minimum price, maximum price, product count, and this response has come. And this is query parameter because this is available not in the path but in the query. That means in get response it is available as question mark and then key value pair of parameter name and value. This is about the query parameters. So you can also have query parameters, you can have header parameters. Here authorization method could be the header parameters. You may have bean parameter if you have to pass the complex objects that could be passed. So there is something called bean parameter as well. So if you have multiple query parameters, then your code may not look good. But when you have bean parameter, here we have specified it params, and then this product search parameters is defined as a bean, and we don't have to pass these as individual objects. We can pass them just as one object. So this is an example of bean parameter. Then handling request and response. So here you will get the corresponding object. So here you see that, okay, when I'm calling, it is returning me the list of products. So whatever is the type of the call, then same is the return type. And we can do different kinds of requests, which could be put request, post request, delete request, fetch request. And there could be asynchronous operations as well, which is fire and forgot. This kind of operations will not return any value there, but they will have a callback URL, and the request will be returned. The response will be returned as a request to the callback URL. This we have seen in the previous video, which was on the webhook style REST APIs. So we have defined all the CRUD operations. We have multi-part data formats as well. So there is an example of multi-part data as well. So let's look into this. What if I provide a URL from where to retrieve products? then this will get from a particular URL. Okay, so this is using builder pattern, REST client builder. So I can try it out, execute. It gives me the REST client builder and then result of all the products. Then there is batch processing. We can say that, okay, these are the parameters which we would like to pass. So we can say here, rather than 0 product IDs or even product ID. If I just give the number, it should return me list of properties. What about ID? Checking a product. So product ID 1 exists. Then you have configuration loaded at the runtime. We can try it out. So this is configuration loaded from the properties file at runtime. So you have various options. This is from environment variable. You have to define what's the environment variable. If you don't define, then that's a problem. So this is another example. Then we have compare ID. So filtered client and non-filtered client. This is what we have to learn next. So let's look into that about filtered clients. So that should conclude filters and interceptors is what we'll be covering. So multi-part is for sharing the form information or file upload or uploading an image. These kind of applications could be created using file upload or multi-part APIs. JSON arrays and collections could also be handled. You can process JSON also if required. Now exception mapping also, we saw that okay, we can have a custom exception mapper. So here this is the class and it can map different responses to different exceptions and return accordingly. So this is about error handling, very straightforward. These are the response code and then associated exceptions. So this will return the appropriate exception, ensures easy exception handling. So implementing filters, they intercept the HTTP request and it allows us to modify headers, URIs, and even the requests. So let's look into some example where compare ID. So here so you see this is the response. So you can modify the response using filters. It could be used for header propagation. So you can have the cache control also implemented using filters. Then there is the concept which is about writer interceptor. So modify request bodies during serialization. And then there could be reader interceptors, which will be modifying response body during deserialization. So here GZIP deserialization is being implemented using interceptor, and writer interceptor is writing logs. Then there is a validation interceptor, which can read the body, which can validate the response and depending on it, modify the response. So in the client, you can register providers. Providers could be filters. So this way, in a declarative manner, you can modify the behavior of the client. So you can also control the priority. So if you have many interceptors and filters, then you can define the priority from 100. So lower priority means it will be executing first. So here is an example of controlling the priority of filter. So this concludes our session on the REST client. So we covered about how to create a REST client using declarative API, how to create an interface, how to create it using builder pattern, how to uh, take care of different kinds of methods, HTTP methods, how to take care of multi-part form data, how to configure the REST clients, how to implement filters and interceptors. So these are all the concepts which are associated with REST clients. So now I'll be sharing in the comments all the details about the content which I have shared, and in the next sessions we will cover more concepts about REST clients and REST APIs. If you have any queries, feel free to post them in the comments. Thank you.